Hey everybody, before we get started, I wanted to let you know about a new event. Today, June 21st, is Control Automation Day, brought to you by Control.com. Control Automation Day brings you industry education about PLC control systems, live, straight from the experts, and keynotes include Dan DeYoung from Rockwell Automation and Moore's Lobby alumni Massimo Bonzi, co-founder of Arduino. Go to Control.com to sign up now. You can also watch it on demand if you're listening to this podcast later than June 21st, and everyone who signs up is automatically entered to win one of two grand prize packages, including an industry-standard Rockwell Micro 820 series PLC and an Arduino Pro machine control system. Go sign up at Control.com. Okay, on to the podcast.
It's great to do this on, 10 cars, but what about 100? What about 1,000? What about 10,000?
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Daniel Bogdanoff. Getting around town is hard, Cars don't just drive themselves, at least not yet. Today's guest is trying to change that. We're joined by Zach Little, the VP of Firmware and Hardware Engineering at Argo AI, where he's leading technology developments in long-range single photon lidar and a full-service autonomous driving tool suite for AVs for companies you might know, Ford and Volkswagen. He's also worked on some iconic tech that you've almost certainly owned, but I won't spoil what that is. You'll have to keep listening. Zach, thanks for being here today.
Thanks. Excited to be on.
I'm curious, did you know that tech was for you, or is it something you kind of fell into?
I think I always knew when I was in junior high, I did this thing called Odyssey of the Mind. And, interestingly, throughout my career, I found a lot of people that are engineers did this. We built these balsa wood structures. They weighed 15 grams. They had to put as much weight as you could on them. And we actually won the world championship in junior high at this. And afterwards, our structure had held 800 pounds or whatever it was. And the team, their college teams, a team from MIT comes up and their professor is like, hey, could you teach these guys how to do it? Ours only held, 300 pounds or something like that. And I think that's, kind of when I first knew that I might be pretty good at this. It might be okay. As I grew up, I was the kid in high school that was, learning how to code when everyone else was, out doing other things. So that had always been a driver for me. My dad was an engineer, which helped a lot. So that's kind of how I kind of knew it. I think for me, it was kind of baked in the cake from day one that this is where I was going to end up.
I did Destination Imagination. It was very similar to OM. And we did the balsa wood thing. We had the same thing where all our test structures held 300 pounds, and then we got to competition and we just kept putting weight on and our eyes got big. We're like, we ran out of time because we didn't put weights on fast enough.
Yeah. A true story at our state competition, the year we won it, we actually ran out of weights.
Wow.
We're putting them on and we run out of the 45 pounds, we run out of the 35 pounds.
Yeah.
And at the end of it, we're putting these 2-pound weights on. And finally, I think it was because someone just dropped one. It finally exploded. It was loud. It was in a gym, right? You get the echo throughout it. And, it sounded like, 10 guns got shot at the same time. And, but yeah, it was, I love that stuff for the kids. It's a great way to introduce engineering without, the stigmas that sometimes come with it. And I think, as I said, a lot of the people that I've met throughout my career, I've heard of Destination Imagination too. They're just great ways to get people into tech.
So you said your dad was an engineer. Did you grow up getting engineering concepts fed to you either overtly or subtly, or was it just kind of a culture of your house?
I think it was more, culture in the house. He, if something went wrong, he wired the house at home, right? I don't know the quality of it, but, I grew up with that a little bit. In high school, I did actually go in with him, work. He worked in the automotive industry and pressure sensing. And I remember going in, helping him put, sensors into reliability tests and things like that. Looking at the circuit analysis on the board. He probably annoyed him quite a bit because I wanted to know why this, why that, why is this like this? What is an RC constant? All of that type of stuff. So I got good exposure to it. I think it really helped steer me to Double E specifically. I knew, am I going to write code? Am I going to do electronics? Am I going to do mechanical engineering? I love all of them. They're all fun. him doing that, I think, kind of steered me down that path. I just felt I had a lot of flexibility, and yeah, that's kind of how I ended up that way.
Did you have a focus in school? Were there any courses or topics that really stood out for you?
Yeah, I think it was my electronics class. You take your kind of circuits one, and you're like, okay, like this is fine, whatever. But it's when you get transistors that it becomes fun, right? No offense to the passive components. I don't mean to hurt the feelings of resistors and capacitors, but it's when you start doing things with op amps, with transistors. I just remember that first electronics class just being fun, right? Like it was challenging. And it was no longer like, before you had like, it's very formulaic, right? You go through circuits, you solve voltage, current, whatever. You get into these complex electronic circuits, and you had to, it was no longer just formulaic. You really had to understand it, the concepts in order to be successful. I think for me, that was a really big one. And then the labs that went with it, right? We made a calculator as our final lab project, right? And you're like, oh my Lord, I made something that's like useful. I use air quotes. I think it was a 2-function calculator. I don't even think it had 4, but I remember connecting that. And that's, of course, the first time that, you accidentally hook up ground to power and power to ground and like blow up, an IC. But, I think that for me was the first time I really like really, really enjoyed it and was like, okay, this is what I want to do. That's what I'm going to be doing when I graduate.
And what did you do when you graduated?
Yeah, so I went to Motorola, by happenstance, I guess. It was in the Midwest. I'm from the Midwest. They were just out of Chicago, outside Chicago at that time. And I started. I was in this new technology called 3G back then. That they divided their handsets by, was it an Edge? Was it 2G? Was it 3G? So we were 3G. We thought we were the cool kids because that was the new thing. I actually got pulled into one of the Edge products, which was Razr, because they were, is obviously a very big product at the time for the company. So that's what I was doing. I actually specifically did ESD testing on it. So I was just sit in the lab and zap, bleed the charge off, zap, bleed the charge off. I had this big sheet that was like, I think I did the math. It was like 100,000 zaps or something
Oh my gosh.
that we had to do to test the product. But that's kind of where it started for me. It was a lot of fun. Learned a lot at the time from it. When Razr launched, like I don't know if you remember that, it was iconic,
Oh
right?
yeah.
That was a sexy phone, right? Like it was just fun to work on it, and I think that's when I got like addicted to working on like the in thing.
Yeah. I think like you weren't anybody unless you had a Razor phone. But
Yeah, I think so. It was. I was just watching the show House recently, like rewatching it, on Netflix or whatever it's on, and I was like, in the show they have that's like the phone in the show, and I'm like, oh man, if it wasn't for that, it wouldn't be so dated.
well, that snap is forever ingrained like into my subconscious. I remember people just like walk down the hallway in school snapping it. And yeah.
Yeah, and funny enough, the other thing is it actually had an outside display and it had kind of the original incarnation of the forward-facing camera,
Sure.
right?
Yeah.
We could credit or blame, depending on your point of view, that with the selfie. Like that's really where it started.
You invented the selfie. Is that what you're saying?
But yeah, it was my fault. But yeah, and I remember back then, video calling, like people are, oh, that's never, that's not going to happen. The networks don't have the bandwidth. You could think of all the excuses in the world, but it obviously now, with FaceTime, WhatsApp, like all of these things, that's, you expect that as part of the experience now.
So you were working on what was arguably like the coolest consumer product at the time, and then you went somewhere else. What was that like moving and leaving that behind?
Yeah, I think for me, I'd been in the Midwest my whole life. I just wanted to go try something new. And in full disclosure, my brother had gone out to the West Coast before me. He's my older brother, like, the cool kid in the family. I remember visiting him, out in Redmond, Washington at Microsoft. And, this is very common in tech now, but they had free drinks, free Coke and everything. I just remember like the campus had such a cool feel to it, such an energy. And I was like, I want to come be part of this. And then I joined, at the time, it was the Windows core team. And it was a huge change to go from, very high volume electronics, things like that. I was working on driver stacks and the like within Windows, but the one very similar thing was scale. Windows is, still probably the most pervasive software platform on the planet. And what you really realize there is, every scenario had to be covered, every configuration, everything. And even with that, you'd still miss things, right? In your testing. And so that was part of this transition. Also, was moving to software, right? Where you have a little more flexibility in hardware. If you make a mistake, it can be months or years, right, to correct it. Software, you have a weekend free and don't want to sleep for a couple of days, you can probably catch it up. It was definitely a learning experience there. And it was, I was working on kind of the other side and having both sides of the fence, right? Understanding, as a hardware engineer, you're like, oh, they can probably fix that in software. And in software, you're like, man, why can't the hardware guys just do it right to begin with? Having both sides of that's pretty important in developing a product in the long term.
Do you have any takeaways that really stuck with you from your time at Microsoft?
I think the thing there is you always have to be evolving. You always have to be learning. I joined there for Windows Vista, right, which is probably not the proudest moment, but I was also there through Windows 7, which was kind of is one of the proud moments, right? It really like revitalized them and stuff. But they totally changed development methodologies. They changed how it was built. It became way more structured. It allowed them to be more predictable. I think that's, stuck with me is constantly be evolving. Look at yourself. What can we do better? What were the mistakes that led to that? And I think whether you're in hardware, software, mechanical engineering, anything you're in, the same thing applies. What lessons can you apply to the vNext? Should we be doing the vNext? Should we just be doing continuous improvement? Like how do we do it? I think that's what stuck with me. And if you look at them as a company, they've done that, right? They really have reinvented themselves from this, operating systems company to a cloud company, right? And if you don't do that, right, you're going to struggle in the long term.
Well, I'm going to implement that advice immediately and reinvent the next 30 seconds into a quick break. We'll be right back. This episode is sponsored by the Exponential Technology Group, part of TTI's family of specialists, who is an expert in all things IoT. XTG's engineering team can literally take an idea from the back of a napkin and produce a full product design, from the proof of concept level to software development to cellular carrier specifications in their in-house RF lab. They have been designing wireless devices for marquee customers since before IoT was even an acronym, and as part of the TTI family, they are attached to one of the largest inventories of electronic components on the planet. The latest information on product lead times and availability is considered throughout the design process, and as soon as your bill of materials is fixed, they can pipeline inventory to support your production ramp. Utilize the support of XTG's engineering team to streamline your next product development project. For more information, visit exponentialgroup.com/EETech. That's spelled XPONENTIAL group.com/EETech. And we're back with Zach Little, VP of Firmware and Hardware at Argo AI. Zach, you mentioned the Razr camera. I understand you also worked on another pretty notable camera system.
Yeah. So when I was at Microsoft, I was loved a lot about it. What I didn't love was the weather in Seattle. So after about 5 years, I was like, look, I have to go south. I have to go somewhere where there's less rain and more sun. So I looked at places, and interestingly, a lot of my coworkers from Motorola had matriculated to Apple over that time, and got in touch with some of them. And my boss at the time, John Kerr, came and pitched me, and hey, we've got this new team. We're doing cameras. You should come down and join it. And at the time, I was a little bit of a head scratcher. I was like, really, like camera? I mean, this is when point and shoots were still a thing, right? Like, you had your little Canon or whatever. I was right before, I think the 4S had just been released, which is like the first 8 megapixel, first real camera in a phone. And, went down, interviewed with the team, really liked them. And it was small. I mean, I think it was like 15 to 20 people, something in that range that was all of camera hardware, program managers, engineers, everything. That was the team. Joined at that time. My first product there was actually the iPod, the one with the camera bump on the back of it,
Oh, yeah.
which is, I remember kind of being universally mocked internally for that at the time.
But it's not Windows Vista, right?
Yeah, exactly right. Maybe there's a trend there, but then that actually, it's become the standard on almost every phone now, right? The camera sticks out the back of it. That's what I went down there to do, and it ended up being a really cool time to go, right? I mean, yeah, we started on cameras, and then started adding depth systems to it, Face ID, rear facing depth. It was just a really fun time to join that area of making your phone interact a lot more with you. When I think back, like, the front facing camera, on your iPhone now is orders of magnitude better than when I started on the Razr for the rear facing. But, it's come a long way. The technology is really, in a fairly short time, really advanced quickly there.
It seems like you really excel at projects that combine hardware and software together very closely. What do you think it is that keeps pulling you into those projects?
Yeah, I mean, I think this gets to why I came to Argo. When I interviewed and talked to Brian and Brad, and my biggest concern was, is this really a software problem? Like, are we just going to kind of be drug along here? And Brian puts it very eloquently. It's a robotics problem. You actually can't solve this without both. You need really good hardware and really good software. If you have a good product, you don't get the luxury of being good at one or the other. You have to be good at both. Now, obviously, the software I do is typically the lower level, right? The firmware, expose the hardware interfaces up. I always used to liken it, at Microsoft. No one cares about the USB stack until you plug in your keyboard and it doesn't work. And a mark that you've been really successful is that you just expect to plug in your keyboard and it works every time, right? I mean, if you go back, I'm sure you remember when you used to install drivers on your computer or whatever to get anything to work. That's basically gone now. But I liken it to the same thing here. Like, that lower level software, like the sign that we've done it really good is that people almost don't know it's there, right? It's just doing its job, pretty flawlessly. And we need all of it to work to make, self-driving cars. So that's, what intrigued me about the problem, kind of still doing that today and same path.
What is the problem that you're trying to solve?
Yeah, we're trying to make cars self-driving. And a lot of this comes down to safety, right? That's the number one value of the company. When we start new hire orientation, that's the first thing you'll hear. That's really the mission of the company. I mean, almost everyone knows someone either been in an accident or lost someone in an accident, and really we think we can help eliminate a lot of that. We can do a better job than we do today. And also do it at scale, right? Like it's great to do this on 10 cars, but like what about 100? What about 1,000? What about 10,000? And you have to do that from the beginning to make that happen.
It's interesting. I see that you have two parent companies. One is Ford and the other is Volkswagen. I wouldn't say they're not friendly, but they're definitely, competitors. What's it like to have stakeholders that are competing with each other?
Yeah, I mean, those are two big investors. They are competitors, right? But when you look at what they do, right, at the end of the day, they're both making vehicles, and you start to see similarities, right? They have pretty rigid development processes, and it's not just for the sake of rigidity, right? They have decades of experience making these cars, right? A modern automobile is very safe. They last a very long time. It's not, what happened 30, 40 years ago. You see a lot of similarity between them. At the end of the day, they're similar enough, and you can learn a lot if you learn from both. The thing I would point out though is they do operate in very different places. I mean, Volkswagen's obviously worldwide, but their headquarters is in Europe. If you go drive on a street, in Europe, it's a lot older than the U.S. is, right? They're a lot more narrow. Stoplights are in different locations. It is different, right? If you can't just take a car from here to there and be like, oh, it's all fine. So we've learned a lot about what's it take to make a car in Miami versus Munich, and it is different, right? There are a lot of differences in that. There are also a lot of similarities, right? Pedestrians are still the same. They're still going to jaywalk in front of you. People aren't always going to use turn signals. People are going to run red lights sometimes. There is a lot of that. Learning those differences has been interesting too.
So, how big is your actual scope? What are you focusing on at Argo AI?
Yeah, so we do both we call it the SDS or self-driving system, and that includes both the hardware, software required to make the car self-driving. So in our case, we work with, as you said, the two big OEMs, Ford and Volkswagen. They provide us base vehicle platforms. an interface to those. And by interface, I mean a steering interface, a brake controller, basically the standard vehicle things. They'll also let us know if there's something wrong with the car. We get the standard diagnostic codes, things like that, so that we can pull over if there's an issue or something like that. But we basically build all the stuff on top of that that's required to make the car self-driving.
So essentially the brain of the self-driving system, and then you tell the car what to do. Is that fair to say?
Yeah, both the brain from the compute and stuff, and I guess the sensing systems, right? Our cameras, radar, lidar, kind of the full set of things required to make it self-driving.
And you mentioned earlier that to solve this problem well, you have to be really good at the hardware and really good at the software. Are there any special challenges on the hardware side and any special challenges on the software side that have been either surprising or you have a fun take on how to tackle that challenge?
Yeah, I obviously I'm way more familiar with the challenges on the hardware side. I think on the software side, if you ask them, like the challenge, for anything, consuming that much data, it's just like how much compute do you have? How much do you have to optimize? Now that's grossly oversimplifying the challenges of that team. But I think that's kind of on the software side. On the hardware side, the real challenge comes in that you're taking these servers that are far more similar to something you'd see back-ending Google, Facebook, Amazon, and you're putting it in the trunk of a car, right?
Yeah.
The great thing if you're in a server rack in a chilled building, is that you don't have to worry about thermals too much. There's not a lot of vibration. It's a very different reliability model. And we're taking, much of these same chips, right? These really powerful processors, these really powerful GPUs. They're also very expensive. And we're putting them in a rugged environment. It's not, a military grade environment, but it's harsh in these vehicles, right? And if you look at the cities we're operating in, Miami and Austin, hot, humid, very different challenges there than, say Hamburg or Munich, where it can be very cold and windy on days, right? Figuring out how to ruggedize those and not just, the compute's the big expensive thing, but all of the sensors, the cameras, the lidar, particularly lidar can be challenging. That's a pretty new type of sensor on a car. That's really one of the very unique things in hardware. How do you make it work for that? Also in a server rack, like power supplies, right? To the audience watching here, right? Like, we've all spent time debugging that under ideal circumstances. On a car, right? It's not a super clean supply, right? Like, how do you deal with that type of an issue? We both do internal combustion and electric, on the various platforms. There's just a lot of challenges with the environment we're trying to do this in.
That sounds tricky, really tricky. I'm always surprised by automotive, just temperature spec, like minus 50 to 150 C or something like it's insane the range that it has to work on.
Yeah, and that's where working with Ford and Volkswagen is helpful, right? They haven't built stuff like this before, but they have put electronics in these cars, and those specs come. They don't know if this vehicle is going to be operating in the backcountry in Alaska or in Phoenix in the middle of the summer, right? That's where all of it comes from, and leveraging like their design rules, their supply bases, things like that really helps you with it. And that kind of drives your designs a bit, right? Our servers probably are significantly larger than you'd see elsewhere, but that's to mitigate having to operate in those upper temperature ranges or lower temperature ranges.
It's time for another quick break. We'll be right back with Zach Little of Argo AI. This podcast is sponsored by Allegro Microsystems, a leader in sensor and power ICs who is here to deliver the semiconductor solutions you need to create a safer, more autonomous future. Their ASIL-rated devices offer the latest, most advanced technology and algorithms to help you meet the stringent requirements of safety-critical automotive applications. With Allegro solutions, you are prepared today to meet the challenges of tomorrow. Learn more at allegromicro.com. And we're back with Zach Little, VP of Firmware and Hardware at Argo AI. Now, I'd love to chat LiDAR. I know it's been kind of a darling and maybe even a little controversial in the automotive space. Why LiDAR for Argo AI, and how are you approaching that technology?
Yeah. So, I mean, LiDAR in general, if you go through the sensors, cameras are great. They're high resolution. You get a ton load of data with them. They're up very computationally expensive to analyze that data. But the one thing you don't get great out of cameras is high precision depth data, right? You might know there's a car there, but is it 5 meters or 25 meters away? Because that'll have a big difference in how you react to it. LiDAR gives you that, right, with very, very good precision. So that's kind of like where we start. That's why it's such an important sensor, right? Knowing exactly how far away things are, how to react to it, etc. We have two lidar types of lidar in the vehicle. One is we call it long range, right? So think from 5 meters out to 200 plus, 250 plus from the car. That's our long range. Then we have some that are like lower around the belt line of the car that are short range. So think 0 to 20 meters, right? We use both of those. As you can imagine, if you're mounted on the top of the vehicle, you've got line of sight things. Like if you want to see straight down, you're just not going to be able to do that. Whereas with those short ones, we can see, if they're 2 feet off the ground, we can see curbs, we can see, parking meters, we can see all that stuff with it. So generically, that's what we needed LiDAR for. That's how we've approached it top level. Within the industry, as you alluded a bit, like it's, aside from like, do you need LiDAR or whatever, we'll come back to that if we want to. But there's been a challenge that there's been many promises. There's a lot, probably 50, 60, 70 startups in this space. Lots of promises, but to the ruggedness thing we just talked about, like it's not just about building it. This has to work in a pretty harsh environment. So being able to deliver that. So Argo acquired a company, Princeton Lightwave, to do our long range LiDAR sensing. Princeton, the TLDR on them is they were doing LiDAR, Geiger mode LiDAR, single photon in the defense industry. The great thing about that is that means that the robustness part of it, if there's something that's more than automotive, it's defense, aviation, those areas, right? So a lot of that was there and it's a proven product. Now, the thing you generally don't get in defense is scale, right? So that was where kind of the problem is. But the LiDAR is, there's a lot of uniqueness. Brian from his past and a lot of our leadership had struggles with LiDAR, in any autonomous vehicle you get. It's been a challenge for the industry for a long time. And that's why we really decided to bring it in-house. We wanted our fate in our own hands, looked at a bunch of companies back then, settled on Princeton, and I've been working on it since then. That's at the top level, kind of how we ended up where we are. We can talk about some of the details of it if you want to, or
Okay, so what is Geiger mode single photon lidar? How does that work?
yeah. So what it literally means is we are sensitive to a single photon of light. Corollary to that would be a linear mode lidar, where you need thousands, tens of thousands of photons to trigger an avalanche in the detector. For us, we just need one. And the advantage of that is that we can see very, call it dimly lit, but like really low reflectance targets at range. An example of that is black cars, which make up approximately 20% of the vehicles on the road, are as little as zero point 0.3 or some are even less than that reflective.
Yikes.
So within the LiDAR industry, often people say we can see to 200 meters. And kind of the industry standard is to a 10% target, to a 10% reflective target. Well, if you're going to a 0.3% reflectance target, all of a sudden you're not going to see it at 200 meters. You're going to see it, maybe at 30, 35 meters. So for us, we're able to see those really far out. For us, that unlocks highways. And in general, it just makes it safer, right? We see those much earlier than the other systems would see it. So that's the positive of it. We also operate at a higher wavelength that allows us to put more power out, so that helps too. So yeah, that's kind of the key differentiator in the Argo LiDAR. And that technology, the detector itself, is actually developed in-house. We actually fab those. We work with the fab to do that. And that's all done in-house.
Very cool. So is the sensor then like very band sensitive to get down to that sort of resolution?
What do you mean by band sensitive?
So like, are you only looking at a very specific wavelength of light?
Oh, correct. Yes, we look at a very, very specific wavelength of light, and for us, we picked it. Essentially, you look at a number of factors, right? Such as like what's the water absorption of the wavelength, what does it reflect? You look at solar absorption. you look at like where's the sun, right? Look at the full spectrum of where the sun is, and you basically, you take all these factors and you're like, okay, what's going to have the least noise, give us the best returns, etc. And that thus we also develop our own laser diodes in house to have a very specific wavelength to avoid as much of that as we can.
I'm starting to see how working on an iPhone camera could really translate to LiDAR.
Yeah. Well, and I mean, they added a lidar to the back of both their iPad and their iPhone, right? So
Yeah.
there's a lot of overlap there.
Were there any challenges getting LiDAR up and running?
Yeah, yeah. I mean, so this was the first team I came over to lead. Actually, was the lidar team, and I think as I said earlier, they had a working product, but there's a big difference in the volume. So I think the biggest challenge is the difference between making 10 of something and being hey, we need to make thousands of these. Let's not even worry about the tens of thousands problem yet, right? Let's focus on the thousands. That's a big challenge, right? I mean, any engineer can appreciate that. So getting the thought process like that, getting partners on board, right? We don't go it alone. We have big CM helping us. Like that whole onboarding process of how do we do this? What do we want to do ourselves? What do we want to have someone else do? How do we make sure that we don't lose the ruggedness in doing that? And then there's the higher level trade offs of what's the field of view? How many points do we need to land on a cyclist? All of that type of stuff wasn't really settled when I had started. So, and when you basically realize if you can get stuck in analysis paralysis very easy. And that's where, the leadership has been very good about saying like, here's the stake in the ground. Like, this is what we're going to go do, go build it.
I heard there was a time that you thought you found a bug in your LiDAR, but maybe it was something different.
Yeah. So when we got our very first lidar up and working, so Argo lidar we refer to as AL internally, and the AL1 prototype, the first unit we get, we're out in the backyard. It's in New Jersey, just outside of Princeton, and the thing's going. We're analyzing. We look at it and we're like, oh man, there's a weird like step function in the point cloud, and we're like, oh, we must just have our bins wrong, or there's something weird going on in the DSP or the firmware somewhere, something wonky. Go look at it. Few hours. Few of us are back at the office later that night, and we're all like, no, it looks fine. Like we can't find a bug here. We don't know what's wrong. And someone just happened to be looking at the top down view on Google Maps. And as it turns out, like a few hundred meters, there's another building, a highway, and then beyond that, another set of buildings. And the building was actually a zigzag. And what we were
Huh.
actually doing is imaging that building from hundreds of meters away. And that's what the reflections were. It just hadn't occurred to any of us that we were actually seeing it that far out. So it was kind of an aha. You're like, oh, this is pretty awesome. Like this thing has some performance behind it.
Is the range just a factor of like lensing, or what impacts the range of a LiDAR?
There's a lot. So some of it's the laser power you can output. So you have to be eye safe. And as you go up into 14, 1500 meter nanometer, sorry, wavelengths, there you can output more. It's more skin safety. Eye safety still matters, obviously, at that. That's one, and that's kind of controlled, right? There's just an amount of laser power you're allowed to put out. It's an energy. It's very well defined. You can do that. Now, on top of that, yes, it becomes okay. So that's what we're putting out. What's the lens? How much of that are we getting back? And the sensitivity of your detector, what type of a lens? Similar to a camera, if you have a very high f number lens, you can get a lot of light back, right? That's what it comes down to, and thus where the Geiger mode is super important, right? I don't need to get 100,000 photons back to get a good instance. I just need one. And you're probably wondering, well, if you just get one, how do you know if it's a really bright or really dark target? And what we do is we just very rapidly send trials. And then based on the statistics, we can essentially tell what's the reflectance of that target. So we essentially use statistics based on a lot of trials to tell how reflective things are.
Like a Geiger counter. So when I hear Geiger, I think of radiation, and the clicks go up, right?
Yeah, and that's what it's doing. A Geiger counter, right, where that noise is coming from is, obviously if it, you hopefully you're not around a bunch of radiation,
Right.
but it's literally just like a single individual signals that you can go and then you amplify it and go from there.
Other than engineers, I don't know that anyone's ever looked at a LiDAR-equipped car and gone, dang, that thing looks beautiful. Uh, the big hump on the top. Is that ever going to go away, or is that just going to be kind of part of the future, do you think?
Yeah, I don't think that it's necessarily part of the future. Right now, we're focused on function, right? Like we know with any technology. I mean, think about your first cell phone back in the mid '90s, right? I mean, it was a big brick. It was in your car. You probably had to have plugged into a power source in your car. You probably had an external antenna on it. I think of it in much the same way. We're kind of at the early stages of this. It would be great to go to super integrated inside, behind the windshield or something like that. That's just not where the industry's at right now. We need to get the function work first. And I think that will happen, right? I mean, you see this in almost every space in electronics and more broadly technology. It starts off with something that's really cool, and then you kind of refine it over time. We're at okay, we have something really cool. Let's get that, prove it out. Let's get it in a product, and then we can, start to shrink it down from there.
Okay. And honestly, I could probably talk about LiDAR for the whole hour, but I know you do a lot more than that. Can you tell me a little bit about your autonomy platform?
Yeah, so we said a little bit. It's the lidar is part of it. We also use radars and cameras on there. Within cameras, we both have we call them far field, but think looking out, similar to the ranges of lidar 5 to hundreds of meters away. And we also have near field, more like fisheye type cameras to see very close to the vehicle. But then the super fun parts is the compute system, right? What do we have in there? And generically, it's a very very powerful server inside there. Multiple GPUs, multiple CPUs. We need redundancy, but you need a lot of processing power. A bunch of high resolution cameras. You need a lot of GPU to send that through your neural nets. So all of that stuff in every part of that, how do you send the data over that? Believe it or not, the common, you're not going to send MIPI from a camera, 4 meters, 3 meters away on a cable. So how do you do that? How do you serialize it? What's the technology for that? All of those things are things that we do both within the hardware and firmware team. And obviously jointly working with our partners in software, hey, what's the right thing to do here? What latency can we tolerate? And even problems you might not think about is, our LiDAR is rotating, right? So you actually need to expose that camera simultaneously as the sweep's coming around. So every one of these sensors has to be exactly timed to each other. It's a fun problem space, right? If you like hard problems, like this is a fun place to play.
What's it like integrating? So you mentioned, timing. What else is challenging about integrating all these different types of sensors?
Yeah, I mean, as you said, one of the things is like there's this big, we call it a tiara on top of the vehicle, right? It makes us feel like we're queens and kings. But how we do all of that? How do you keep those things? If we're operating in Austin in the summertime, it's hot, right? Like, how do we keep all that stuff cool? Our vehicle interfaces team does a tremendous amount of work working with our OEM partners for how to do that. And another really unique thing, Beth Ballard on my team runs this. How do we keep these things clean? We can't just have a bird poop on the camera and be like, oh, like I'll next time I go to the car wash, I'll get that out, right? We've got to make sure that doesn't happen, or if it does, we can very quickly get it off the lens of the camera or the lens of the lidar. So those are really big challenges. That's not something that has really had to have been dealt with in this manner before, where you've got cameras. These things are real time steering the vehicle. Dust particulates, rain, things like that. Like we have to be able to keep all of these sensors clean so that we can operate under conditions everywhere.
Well, it is time for a quick break. Maybe you can go clean off your windshield or your LiDAR sensors. We'll be right back. This podcast is sponsored by Control Automation, all about Circuit's sibling site, which you can find at control.com. We're hosting our first inaugural virtual event, Control Automation Day 2022, on June 21st. That's today. The event is PLC themed, and there will be a bunch of live sessions, as well as coverage of the latest trade shows, product announcements, PLC ebooks, technical articles, and more. If you missed it, it's not too late. All of the live sessions are available on demand for free. including our keynote with Dan DeYoung of Rockwell Automation and Arduino co-founder Massimo Bonzi. You could also win one of 2 grand prize packages, including a Rockwell Micro 820 series PLC and an Arduino Pro machine control system. Sign up for Control Automation Day by going to control.com. You won't want to miss it. And we are back with Zach Little. Zach, I'm curious, is it easier to integrate with an electric vehicle or an internal combustion engine vehicle?
For us, there's not a big difference. We get the supplies from them. One might be a higher voltage supply. So, you just put you put the electronics to distribute that within your system. But for us, honestly, the difference isn't that significant. Now, on the vehicle interface side, if you've ever driven an electric vehicle, it does drive quite a bit different, right,
Yes.
than an internal combustion. So I think that's where we see the bigger difference. My friends in Autonomy would be way better to answer that than I am, but I think that's the bigger difference.
Okay. What was it like coming from consumer electronics into automotive?
Yeah, I think the biggest thing is that in consumer electronics, we're on a podcast in our computers right now, right? If one of ours crashes, it's not the end of the world, right? We reboot, you edit this out. It's not a big deal. If the car's compute system goes down, that's not good, right? So, I mean, one, we have a redundant compute system. We have a second one to take over. But the big difference is that, in consumer electronics, like the design, the size, power, very, very important. For us, the stability of it, right? More closely resembles something like avionics. If you're in a 737, you obviously don't want the flight computer going down, right? For us, it's more like that, right? And you see that in the designs. The circuit boards are bigger, they're bulkier to allow for the robustness in the design. So I think for me, that was the biggest change. The other thing, as engineers, we super love this part, is the documentation and formality and requirements. I mean, a number of things in consumer electronics are like, oh, well, Joe over on that team did this, so it's cool. Like, he's really good. And here it's like, no, 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 no. Like, this all needs to be written down. We need to have it documented. We need to have a requirement. There needs to be traceability. That was another big change for me is all of kind of that stuff, which at the end of the day, it all comes down to safety, right? Making sure we've covered all our bases.
So let's talk a bit about designing for safety versus standard design on a consumer electric device where you're basically just trying to pass your EMI tests. What are both mindsets and maybe some actual design techniques that you employ to make sure that things are safer and as safe as they need to be?
Yeah, I think the easiest example of this, particularly if you're an electronics engineer, is WCCA, right, or worst case circuit analysis. That's something that in theory, if you do a good design, in a consumer electronic or an automotive device, you do analysis, simulation, et cetera, of this. But in automotive, there's a very formal process for going about it, right? And you really are taking every circuit from, the power circuits, the high speed signals, I mean, everything in there. And you're really analyzing down to the resistor capacitor level. Like, if that capacitor doesn't work, what happens? And it's a formal way of doing it. It's all documented. It's reviewed, right? In our case, it's reviewed by our OEM partners, right? As well as our suppliers. That when you're talking about designing for safety at the lowest level, right? Like that's a good example of a process that's unique to automotive, right? And that's something, if you're interested, go look it up online. But that's a process. It's a very well defined process for like, thou shall build a circuit board like this, and here is how you shall analyze it.
Okay, lots of rigor.
Yes, lots of
It almost goes back to your ESD testing on the Razr phone a little bit.
Yeah, it does. I mean, I remember, on that phone, the guy who had done the prior one spent like the prior 6 months just adding ESD diodes and stuff. That was the best ESD design phone you've ever had. I mean, you apply that rigor, to it the next time. But here it's, a process to ensure that as opposed to a person.
Okay. And then you've developed solutions for smaller vehicles like the Ford Escape Hybrid and also a bigger Volkswagen van. How do those systems differ and what are some common threads between them?
Yeah, for the most part, the hardware on them, both the sensors and the compute systems are the same. Now, what varies is the integration onto it, the wiring, the harnesses, all of that stuff differs a bit. But I think the bigger differences are actually outside of what I do. They're more on the controlling the vehicle, right? A bigger vehicle just flatly controls differently. So, our team that does trajectory planning, right? They do have to do a separate effort for those. But the great thing is, other teams like our mapping team, we're using the same map between the two, right? There's a lot you can leverage between the two. So that's kind of where the difference is. It's really more in the controlling of the vehicle. And in our case, beyond controlling, it's two different OEMs. They have slightly different interfaces to those controllers as well. So that creates an additional work stream as well.
So it's kind of the core central technology stays similar, but you maybe add some, tweak the variables and the peripherals.
Exactly. Yeah.
Okay. Moving forward to the future, are there any challenges that you're really excited about in the next 10 or 20 years of autonomous driving, or anything that like makes you nervous and maybe keeps you up a bit at night?
I mean, I think for us, how do we get the first 1,000 vehicles on the road? We've got stuff, across the industry. There are small pilots running, in a number of places. I mean, we have our own Lyft, and Walmart pilots, in Miami. But I think how do we scale that out, right? And I mean this in all parts, right? The hardware, the software, et cetera. How do we get that? How do we build the vehicles? How do we monitor the vehicles? And it's the things we don't know about. I mean, you think about when you drive every day, there's always something new, right? And how are we going to handle that, right? Is our system robust enough to it? Are my sensors good enough to detect that? And how do we scale it? No, okay, fine. We get the first 1,000. How do we get to 10,000, right? How do we get to 100,000 after that? And you need to be years ahead of that in your engineering development.
Can you tell me more about some of the pilots you mentioned?
Yeah, so for those, I mean, it's part of Argos. We do both. We do goods movement and ride sharing. So, we hit two of the biggest partners in the world for that, right? Lyft. We operate that in Miami. Went live fairly recently. You can actually, go down there, and if you're in the general public, you can select the autonomous option down in South Beach. And if you're within the GeoNet forest, you can go ride in an autonomous car. In Walmart, we do delivery, right, from those. So super cool partnerships. Obviously, those are very big, well-known companies, fun to work with. So yeah, those are live today. So this isn't some like in theory this will happen someday. This is ongoing today.
Tell me about your first time riding in an autonomous vehicle and what was going through your head.
Yeah. So similar to you, I was at CES in one of these, and I get very motion sick. So I was one of the people, like if you put an AR VR headset on me
Yeah.
and there's like any lag between the hours, like I'll just throw up. Like I get very, very motion sick. And in this car, I mean, CES, Las Vegas, we're in this thing, and I would say it was driving autonomously ish. And the mantra around autonomous cars at that time was they accelerate very slowly and brake very quickly. Uh,
Oh.
that did not work super well for me. I
Oh
actually had
no.
to get out. I was probably about a mile and a half from the convention center, and I was like, I just need out of the car.
Oh no.
I won't say who that was with, but that was a long time ago. But I liken that to very recently, just a week or so ago, I hopped in one of our cars here in Palo Alto, and we drove all around Palo Alto, Los Altos Hills, and there wasn't a single takeover, and it was just punching addresses and stuff like that. It's the how natural they're getting now. It's really fun to watch. At times, you almost rely. You didn't even think about the fact that it was autonomous. It was just, oh wow, this is just really cool.
If you had to pick a year, what year do you think you'd own a fully autonomous vehicle?
That's a tough one. I think, as Brian always says, it's ready when it's ready. We're really focused on fleet applications and things like that. Some of that's cost driven. Some of that's that as we're deploying this, we want to maintain control over it. Make sure, as I said, are we covering every scenario? So I think that will be the gate for it. I don't really want to guess a year because I'll look super silly
Fair enough.
either way at some point. So we will eventually get there, right? And you see it now happening where personal cars are getting more autonomous, and then these other vehicles will come down in cost. They'll eventually meet in the middle.
Do you have a favorite autonomous driving or AI entity from pop fiction or sci-fi? And are there any that you've seen and just go, oh, they got it so wrong?
Um, I mean, to me, like I mean, my favorite sci-fi movie is Terminator, so like maybe that's a bad example of autonomy. Let's hope they got that one wrong for all of ours. I would say the other one, and this is obviously got it completely wrong, but it's just a funny one, is Total Recall with Johnny Cab. Like the old Total Recall, the
Yeah,
Arnold Schwarzenegger one, where they had the little plastic guy that would turn around, and
right.
I think that one's a funny one. I don't think our autonomous cars are going to be talking to us like normal rideshare drivers anytime soon.
Let's
But
hope not. If you could engineer another autonomous vehicle besides a car, what would it be?
so I'm super biased in this space. I have a pilot's license. So for me that, and I do both helicopters and airplanes. So for me, it would probably be specifically planes. And some planes, by the way, actually are starting to get this today. Both I think like the Cirrus Vision Jet, there's a Meridian M600. They both have these self landing systems. Now they can't take off yet, right? But you can kind of see the evolution there. But for me, I think that would be really cool, right? To be able to do that, it could really change travel and how you do it. But again, that's a fairly biased view from someone. And yes, I'm totally fine obsoleting myself as a pilot in the plane as much as I enjoy it.
Speaking of skill sets, is there anything you would recommend that engineers focus on or learn so that they can be more relevant or more capable in the future?
What I would say for any engineer, and go through this with a lot of our folks here, is it's really dig into the details of whatever you work on. Really get to know it. We're going to need all these things. I mean, the easy answer is like, yeah, go do machine learning, right? That's going to be really big in the future. Or like, learn how GPUs and TPUs work. But I think what's more important than that is whatever you do, just learn it really well. Learn about how it's manufactured, how it's designed, what are the design rules, why is it that way. Don't just look at it on the surface and say it works. Like really, really dive into the details of understanding it. Both the successful engineers, the successful companies I've been a part of, that's the common thread, is that they sweat the details. They go into gory depth on it. And that's really, like, to be successful, I think a key thing. You really have to do that. Why that's so important is it applies everywhere, right? If you can do that for a circuit, you can do that for a lot of other things as well. The same principles will apply. I mean, that would be my advice to any, young engineer, even mid-career, right? Really dig into that, go understand it, talk to the person that's been doing it for 20 years, pick their brain on what they've learned over that time. That's the advice I would give to anyone.
That is some great partying advice. Sadly, we're out of time, but thank you so much for being here.
Yeah, thanks a lot for having me. Had a lot of fun, and keep on. Love the podcast. Looking forward to hearing the other folks in the future.
Oh, yeah, we have some great guests coming up in the queue, too. We have top engineering leaders from ARM and AWS. So, if you're listening out there, make sure you're subscribed to this podcast to catch those. That was Zach Little, Argo AI's VP of Firmware and Hardware. Thank you for joining me today in the lobby. I hope you enjoyed that as much as I did. And hey, this doesn't have to be the end for you today. Go check out Control Automation Day 2022, which kicks off today, June 21st, and is also available on demand. If you missed the boat, go sign up at control.com. We'd also love to hear from you. Go check out Moore's Lobby and All About Circuits on your favorite social media platform. I'm your host, Daniel Bogdanoff, and I'll see you next time.